This is the last session before lunch. For those of you who are familiar with React, you probably know this already, but so I'll say this. They made an interesting decision when they designed it, which I kind of think of as in opposition to Angular. And the decision that they made was that they're going to very much focus on rendering. It was about how to render stuff. And whereas Angular has, if you read the Angular book, they have this kind of thing. We are kind of a kitchen sink. We're trying to pull in all kinds of capabilities to give you a complete environment. What that means about React is that there are a number of significant aspects about how you actually build a complete application that aren't, strictly speaking, covered by React itself. And Flux is the overall architecture that Facebook has come up, that Bill has come up with, that helps create an environment where you can actually build an entire application, and React becomes the rendering framework within that. So I think it's very interesting. It also has a little bit of that flavor, I think, of reactiveness, in the sense that there is almost a kind of like a data flow or an event flow here. So with that, I'll turn it over to Bill. Thanks.
Thanks. Just to clarify, I did not come up with Flux. Flux is primarily authored by Jing Chen, who is a very talented software engineer at Facebook, and in her conversations with Adam Wolf, they came up with Flux together, and Jing was the one who first implemented it. So just to dispel that. However, anyway, my name is Bill Fischer, and I'm a software engineer at Facebook, and I work on a team called The Factory at Facebook, and we do special projects for Facebook to improve the user experience. And those are projects like the look-back videos, if you remember those, or the recent year in review experience, or there was also a say thanks experience where you could send a video to a friend to thank them. All of those projects were built in part with React and Flux, as are many of our web applications at Facebook. So just a couple of housekeeping things to get started with. If you're looking for these slides later, they're on SpeakerDeck, and there are documentation sites for both Flux and React available. Most of our open source websites start with facebook.github.io and end with whatever the project is. Here's a couple of hashtags in case you want to use those today. So about React and Flux, can I just see a show of hands briefly? How many people have actually taken React for a test drive? Quite a few of you. That's great. So I may be able to cover some of that stuff a little bit more quickly today. And how about Flux? Has anybody tried Flux? Okay, quite a bit fewer of you. And I'm going to be covering sort of like vanilla Flux today. There's been a great proliferation of Flux frameworks because Flux is not necessarily a framework itself. It's actually more of a pattern. We just use generic JavaScript when we build Flux applications, but there are some frameworks out in the wild now that have kind of packaged it up into a framework. So React and Flux are two very separate things. Like I said, Flux is a pattern. React is a framework. They are highly decoupled. You can use React by itself. You can use React with some other architecture. You can use it with MVC. You can use it with Backbone, whatever. You can use it with the Elm framework, for example. Or you can use Flux without React. You could use Flux, say, with Reactive or with some other Vue library. But many of the ideas in React and Flux are similar, and so they complement each other really nicely. They come together to using those same ideas to kind of form a nice cohesive whole. And now a lot of people are using it. So we've, React and Flux projects are now at Yahoo. Yahoo Mail is getting rewritten in React and Flux. Many Yahoo Media properties are being rewritten in it. Adobe Brackets is using it. SoundCloud, Airbnb, and many others. So to get started, I want to talk about a little story that happened to me. This is how I actually got into writing and talking about Flux. Because I was on my couch one day at home and sitting there doing a little bit of work, and I got a message from a friend, a guy who works at Google, and he said, hey, And I'm really excited about this React stuff you guys have going on over at Facebook. But I don't really quite understand how to get started. Like, should I just like, I understand it's just the view layer, right? So what do? Do I like plug it into Backbone or what? And I'm sitting there and I'm thinking like, you know, that's really the path of pain. And let me tell you what we do at Facebook. And this is why. Because when you start building out models in an MVC, you have this nice, beautiful application. Everything's really well planned out. Everything's great, except at a certain point, you have some key piece of information that is needed in one model by another model. And now you have this relationship that you have to maintain. And you've kind of set up this second model as a second-class citizen. It is now it has a dependency on that first model. And usually, this piece of information is actually quite important for the whole application. And it's not just one model that needs it, but a number of them. As the application grows and things progress over time, sometimes there's another piece of information from a different model that is needed across the application. And now you have two dependency trees that you have to keep straight in your mind and you have to maintain. This is a huge problem because the product manager comes to you and says, hey, you know, we want to grow the application and get it bigger. We want to do more things. And you have more models. And this dependency tree mess is continuing. The application grows some more. And eventually, your original model becomes a dependent model itself. And you have no single source of truth in the application. And you have an unstable application state. It's very difficult to reason about. And it doesn't really matter if you're doing this with events, trying to manage this with events, or with setters, or any other kind of like, you know, sort of like direct communication. If you're trying to maintain all this in a model structure like this without any help, it becomes a total mess. You have all these connections all over the place, and you're trying to keep all that straight. You have a new person that comes onto your team. They can't figure out what's going on at all. So this is really a situation where you've got spaghetti code. But it's a different kind of spaghetti code. It's this cascade of updates that's turned into spaghetti code. And this is what we set out with Flux to resolve. So with Flux, we avoid this spaghetti code, and we can avoid that spaghetti code. We can also grow our apps with confidence. Like when we make changes to the application, we know that Flux will be able to adapt to it. We don't have to be afraid that, oh no, that's going to turn into a big problem. And we can also onboard new people really quickly, because Flux has this very simple mental model. This is basically all that Flux is. It's a unidirectional data flow through these key parts of the application. We start with an action. This is how all data begins in a Flux application. It's something that happened in the outside world. Either the user clicked or the server responded. Something actually happened. That action gets handed to the dispatcher, and the dispatcher distributes it to all the stores in the application. And it's important that it goes to all the stores. So the stores are like models. They're like domain models. And then finally, the stores, once they update themselves, they can hand that data to the view. And the view, in our case, is React. So bring it back to the couch here. So the end of the story is, basically, I was able to explain Flux to my friend. Now, granted, he's a talented software engineer. He works at Google and all that. But I think it's indicative of how quickly people can grasp this concept and come up to speed with it and get started. And I've seen this actually myself time and time again. I've mentored a number of interns at Facebook. I teach them Flux in about half a day, and they're ready to go. They're starting to make an impact immediately. So here's the plan for what we're going to talk about today. I'm going to walk through a Flux application following that data flow. We'll look at the actions first. We'll look at the dispatcher after that. When we look at stores, we're going to examine how we test stores. And then finally, we'll get to the views and talk about React. And then I'll talk about some various miscellaneous topics like immutable data and some anti-patterns to avoid. Okay, so this is like a file tree of a Flux application, a very basic Flux application. You can see here we've got the same things going on. We have actions, the dispatcher, the store, and the view. Now those are in yellow. In blue we have some auxiliary models, auxiliary modules that we need to kind of like get the application started and maybe to communicate with the server. And I'll talk about those at the end. Let's start off with actions. Now, wait a second. Yeah, okay. So actions are just objects. That's all they are. They're just a map of keys and values. But they have this one particular important property, which is their type. And the type is going to be what the rest of the application can use to determine how to use that action. We take actions and we create them in methods that we call action creators. And these are just semantically named things that essentially create this simple object, hand it to the dispatcher, and that's it. And these become the sort of the API of the application. This is what they look like. This is common JS syntax. So I'm requiring the dispatcher, and I'm getting some action types from a constants file. And then I wrap them into this method. In the middle here, we have the action itself in yellow. It has that type property, and this is ES6 again with the shorthand for objects. So I don't have to say text, text. This is just text, right? And we hand that object to the dispatcher using the dispatcher's dispatch method. I'm going to give it a nice semantic name, and I'm done. That's it. So next, let's take a look at the dispatcher. The dispatcher is essentially just a registry of callbacks. It's actually it's just a mechanism. We don't actually do any programming inside of the dispatcher. We just utilize it. It's as dumb as a rock. It has no real intelligence of its own. Okay? So when we call dispatch, all we're doing is saying, okay, all the callbacks that have been registered, invoke them now, please. So we maintain it as a singleton so that it can be the single point by which all data flows through the application. It has these three really important methods. It has a couple of more, but these are the three primary ones. Dispatch, which we've already seen. Register is the method that we'll use to register a callback with it. And then wait for. Wait for is its killer feature. Wait for is what's going to resolve that problem that we saw before with the spaghetti cascading updates. When we do eventually have a dependency between stores in Flux, which we assume actually is an eventuality in an application. I'm not going to lie to you and say like Flux is going to avoid all your dependencies. That is eventually going to happen as an application grows. But when you are in that situation, you have wait for to declaratively say inside of one of your registered callbacks, say wait for the other callbacks to finish first. Wait for those other data mutations to take place. Then I can do the work I need to do. And you can do that declaratively inside of a store, which we're going to see next. And that's a much nicer model for maintaining those. You don't have to keep any of that straight. It's very clear in the code where that happens and what is going to be and what exactly is supposed to happen. The base class for this is available on NPM and Bower, and this is the same exact dispatcher that we use in production at Facebook. So if you want to use ours, you can. This is what it looks like we're just basically instantiating a singleton. We're done programming with the dispatcher at that point. Other than that, we're just using its API. So next, let's take a look at stores. And stores are sort of the heart of a Flux application. This is the most important part of Flux, you might say. I mean, the dispatcher is very important as well. But like I said, you're not going to be working with it very much other than to call its methods. This is where all of your programming would happen. Each store in a client-side Flux application is a singleton. Now, some people have chosen to go the route of using instances, and that's fine too. I just prefer singletons myself. I find them to be really easy to use. And as long as I'm not operating in a Node.js environment like Yahoo is, the singletons seem to work fine for us. But more importantly, it is the locus of control in the application. And what that means is that no one else is going to be orchestrating the stores. The stores are totally in control of themselves. Nobody is adding data to them. Nobody's doing anything to them. They are really they are the seat of all power, you might say. They manage the application state for a logical domain. And by a logical domain, what I'm talking about there is like a loosely associated idea that all the things in an application that sort of tightly relate to each other, things that need to know about each other, are collected together in something. Usually that maps pretty easily to like a collection. So we have like a friends store maybe, or a photos store. But sometimes that's something more abstract, like a time store. And then you have everything that's related to, say, elapsed time for an animation. So we just kind of collect them together, and when they get too big, we split them apart. And if we find they have dependencies upon each other, maybe we can combine them, or maybe we have to create a third entity to manage their dependencies. And like I said, we do have wait_for available to us. They have private variables inside them to maintain that application state, and private methods to do the updates, so that no one else can see what's going on inside. They need to have this like tightly sealed, hermetically sealed border around them. And they can contain lots of different collections, or they can contain single values, like I was saying. It could be something abstract, like a time store. It could be like something with collections, like a friend store. They are the ones who are going to be registering callbacks with the dispatcher. And the callback is the only way that data can get in. This is a really important point. There are no setters. It's a complete inversion of control. They define the callback, and so they're managing essentially how they receive the data and what they will do with it. No one else is orchestrating them at all. They do expose a public API of getters. And so these are the two ways of getting data in and out. You get data in through the callback, and you get it out through the getters. And that's it. When you emit change, you're not emitting data with it. You're just emitting the fact that something changed. So now use the getters and come get the data from me. So let's take a look at what code looks like. Oh, wait. Hang on a second. Did I get ahead of myself? OK. So there's a lot of text on the screen. I'm going to do my best here to do something tricky. OK, up at the top, we have a couple of private variables. There's the dispatch token and the messages collection. We're going to expose those out at the bottom in some methods. And so we turn the private variables into protected variables. These are our public API of getters. Now, the dispatch token is what other stores are going to need when they use wait_for. So it's important to expose that. But the real important stuff here is what goes on in the middle. This is the registered callback. Inside this registered callback, that's going to receive the action from the dispatcher. And we're going to switch on the action type. Now, some people prefer to use a map of functions here. It turns out that the switch statement is actually probably slightly more efficient than a map of functions. But it's really a matter of taste. We tend to use the switch statement at Facebook. The other thing about the switch statement is it kind of encourages us not to think of actions as setters, because we have to kind of like extract values out of the action and then call internal setters. So anyway, so let's take a look at message create. What happens in that case? Maybe I can do my little zoom in trick again. Okay, so inside of message create, you can see that we're taking in the action, the text from the action. We're going to create this ID out of a date object. That's just kind of a hack, whatever. And then we're going to add that to our messages collection. After that, we'll emit change so that the rest of the application knows that there's a new message. Okay. Now let's take a look at how we would test that. At Facebook, we use a testing framework called Jest. And Jest is an auto-mocking testing framework that is built on top of Jasmine. Here's the URL for for the page if you want to check it out. Like the other ones, it just ends in Jest. And what happens is with Jest is that we want to mock everything in the application except for the one thing that we're trying to test, to do a true unit test. We're just trying to test the store, nothing else. So everything else gets mocked. That means the dispatcher's methods are going to get mocked, and they're going to receive this mock property attached to those methods. So to get the callback, this is how we're going to actually be able to set up our test, because we have no setters, right? And our callback is an anonymous function. So it's very difficult to do our setup. But this is the one killer feature line thing here that we need in our test. So reading this backwards, what this is saying is, well, let me explain for a second here. So inside the mock object that Jest provides us on the register method, we have a collection of calls, an array of calls. So every time this register method is called, it adds to that array. Okay? And then we have an array inside of each one of those of the arguments that were used. So reading this backwards, we're saying I want the first argument to the first call to register. And that argument, that first argument, is our callback. So we'll put that inside of our test, inside of a before each block, so that we can use it in all of our assertions later on. We can see down at the bottom when we are asserting that it can create messages, we're going to use that callback and we're going to provide it with an object literal. It looks very similar to an action, right, with a type, and it has our text. So we're creating this action sort of right there in the assertion, providing it to the callback. The callback is going to change the store, and then we'll use the getters in our expect method down at the bottom to make sure what we expected to happen has actually happened. And that's how testing works with Jest. That's as long as you know that one trick, it's basically it's pretty easy. So now let's talk about the view layer and React. So React is a component-based system, as many of you know. And we use React because it has a unidirectional data flow and kind of maintains that same paradigm that we're using in Flux. What we do at the very top is that we have these things that we call controller views. Now, some people call these containers or something like that, and they're not really controllers. They really just have this controller-like quality to them, where they're getting data from the model, that is the store, and passing it to the view. Okay? That's kind of the end of their controller-likeness. So we build these up near the root. They usually manage like a section of the page. You might have 4 of them on the page, say, or however many you need. And every time the stores have an onChange event, they get the data that they need, they update themselves, re-render themselves, pass the data to their children, and all of their children re-render. And so we need this sort of paradigm that React provides of being able to say, given any expression of state, re-render given that state. So let's talk a little bit about React and what React is all about. Some people might say that React is a component-based system for managing DOM updates. And that is true for React.js. It uses a virtual DOM. Rich Harris described this very accurately yesterday, where we have a diffing algorithm where we have the previous state of the DOM and the new state of the DOM. We find the diff between those things, and we find the most optimal way to update. And that might be destroying a huge section of the page. You have something up here on the page that needs to get updated, something down here. Well, you're going to have to take this whole thing and just wipe it away and rebuild it. And it turns out that that's actually very efficient, as long as you do it in one fell swoop. Boom. So it gives us this huge performance boost. And big bonus here is that we can stop thinking about DOM, right? In 2010, we all had to think about it a lot and oh man, I'm going to batch my writes and batch my reads and do all this good stuff. But now we can just forget about it, and we have a mental model of re-rendering constantly. But React is actually much more than that. React is more of a programming paradigm. And we've seen this now recently with the with the upcoming release of React Native, where we're no longer going to be rendering to the DOM, but we can render now to iOS and Android. And these are not web views. This is not write once, read anywhere. This is actually learn once, write everywhere. We're writing iOS code. We're writing Objective-C. We're writing Java. It's native code that's running. It's just that we're writing JavaScript components and then compiling them. React is based on functional reactive principles in the sense that, and maybe I'm using that term wrong now, maybe, at least functional, if nothing else. But essentially, it has a unidirectional data flow, like you see in functional programming, and the various components are composable, like functions are in functional programming. And this makes them really predictable, reliable, and testable, just like functions are in functional programming. Ideally, we keep these functions as pure as possible. And so we can declare them what our UI should look like given any state of props. So that makes props become like the inputs to your function. They're like the arguments, in a sense. And if we don't use this.state inside of our component in any way, we have essentially a pure function. Given the same props, it will always return the same output. So the mental model here, again, is that we can re-render at will with impunity. Even though we say, you can see in the console that you're calling like render repeatedly, that doesn't actually mean that you're rendering to the DOM. The render function is just called as a part of the diffing algorithm and does not necessarily mean that you are actually writing to the DOM. If there's no change that's happened, you don't need to actually write to the DOM, and React takes care of that for you. So like I said, we try to keep the components as stateless as possible to make sure that things are as reliable as possible. The component lifecycle and update cycle. This is a really interesting aspect of React, and this is where it's quite frameworky, where these are the hooks in the components that you can provide extra behavior. The lifecycle on the left side is what happens with just it hitting the page or being removed from the page. The update cycle is whenever it receives new props or new state. So let's focus a little bit on the lifecycle side for right now, and we'll talk about how to build a controller view. We're going to use these 4 methods. These are the 4 methods that any controller view needs to utilize so that it can start setting up that listening behavior. So we'll start with a basic React component. This is a controller view, and essentially all we need for any React component is to provide it with a render function. So we've got some things to build out. We'll first start out by setting up that event listening behavior. We'll use component did mount and set up our listener there, and then we'll clean up after ourselves in component will unmount. Now we need to also update the state of the controller view. Now this is a really nice place to use state because it gives us a handle to maintain that data that we got from the stores. So we'll get initial state and we'll essentially return an object literal that has a messages property, getting those messages from the store. And then we'll do the same thing down in onChange. We're essentially saying set state with that same object literal. We're going to overwrite that with the new data from the store. So there's those four methods again. We've created a controller view. Let's look at what we're going to do in render now. So in React we have JSX syntax. So we can use things that look a lot like HTML. This obviously needs to get precompiled into native JavaScript before we use it on the page. So we're going to use that, and we're going to provide it with an array of message list items. What we'll do is we'll pull out of state our messages, we'll map over them, and we'll create a child component for each one. We're going to provide it with a key, which helps with React's diffing algorithm. It has to be a unique value. And then we'll also provide the data that that component is going to need, the message ID and the text. And now we have an array of message list items that we can render down in our unordered list. Here's what the child looks like. Now in the child, we're going to receive props. So we can do some type checking by using the prop types property of the React class. We can say that this is going to be a required number every single time, the message ID that is, and the text is a required string. And if we ever try to instantiate one of these without these things, we'll get an error in the console that's very descriptive and tells us what went wrong. So then down in render we're going to render that as a LI. And but now we want to add some behavior to it. So let's add a little bit more here. And we'll add an on-click handler. And these are the extra things that we're adding here to this. We're going to get our action creators. And we're going to provide an on-click handler. And React is going to automatically do the event delegation for us. So we don't have to worry about the fact that like we're putting this event handler on every single LI element. React is going to take care of the event delegation that we would normally do to keep that memory efficient for us. No problem. Again, like the DOM, like not worrying about the DOM, don't worry about event delegation either. And then we have down in our onClick method, we're going to call our action creator. And now we've come full circle. We're going to delete this message when we click on it. So we're going to come back to our mental model here. We're going to call our action creator for delete message, providing it with the message delete type and the message ID. Inside the store, we're going to have a case to handle that, where we delete that from our messages collection, and then we emit change. When the view re-renders, that message will be gone. And then that's basically React and Flux. So now let's talk about some extra topics beyond that. First, initialization of the app. We need to get started in some way. And so we usually do this in a Bootstrap module where we initialize the stores with an action. And we need to be able to like kind of render the root and get started with the tree. So this is what that looks like. We're going to need to require all of our stores. And by requiring them, there's going to be a side effect on that where they instantiate. After that, we know that they're instantiated, we can then initialize them with an initialize action and then render the React root. And this is basically how it goes. So that gets us started with the data from the server. Now, when we want to call back to the server and with its web API, we usually do that inside of a module called the web API utils module. And that encapsulates our XHR work. Maybe it uses promises or something like that. And we can call that from either our action creators or our store. So there's a lot of people that like think you have to do it one way or have to do it the other way. You have to do it in the actions creator, you have to do it in the stores. But really, either are fine. There are teams at Facebook that do it both ways. But the important thing is that if you do it in the store, you have to remember to create an action in your success or error callback. This is a huge mistake because you're inside the module of the store, and you can quite easily think, oh, I have the messages collection available to me inside the closure. I'll just update it directly. The problem there is that what you've done is you essentially interrupted the unidirectional data flow, and now none of the other stores will find out about the response to that XHR. So what you want to do is always start with that action. And thereby, you've ensured that in the future, when you have some feature that you can't foresee, that your other stores are ready to have that data. I've personally made this mistake, and I just want to encourage you. It's well worth the investment, paying it forward. Just always start with an action. Okay, immutable data. Immutable data, first of all, immutable. I don't want to use too much jargon here. Immutable means something that can't be changed. With immutable data, whenever you want to make a change to it, you have to make a copy. So we can use this simple aspect of immutable data to speed up React's performance quite a bit. we use one of the update cycle methods called should_component_update to do a quick check on whether or not the props or the state have changed. Now, this thing called the pure render mixin will do this for us, or we can write it ourselves if we're trying to avoid mixins. We do have a library for this. I think this is the 4th Facebook open source page that I'm promoting today. Yeah, Immutable.js is a wonderful thing, and it keeps it really memory efficient. You think to yourself, oh, if I'm copying these data structures over and over, that must be a huge memory hog, right? Well, actually, it becomes very efficient because inside of Immutable.js, what we have is an algorithm that's kind of similar to Git, where we're only saving the changes, and we're kind of like have a tree back in history. And that actually becomes very memory efficient and is not a hindrance in any way. And if you want more information about how that's memory efficient, I strongly encourage you to look at Lee Byron's talk from ReactConf, the recent ReactConf in January, where he does a really great job of explaining how this is memory efficient. So here's what those update methods are again. You can see that should_component_update gets called either the first or second thing whenever props or state are called. So what happens there, so what we're going to do is we're going to have just a triple equals inside should_component_update. Either we're using the mixin and that'll have the triple equals, or we'll write that triple equals ourselves. And so what that is, it's saying, is this the same reference in memory? Now, if you've made any change to the data, if you're using immutable data, it's going to be a copy, and it's not going to be the same reference anymore. So that triple equals works to know that anything inside of that huge data structure that you may be looking at has changed or not. So let's see, some more Flux patterns. One is a logging store. I create a logging store for just about any application that I create. And the logging store is really great because, like any other store, it's receiving all of the actions. So anything that happens on the page, the logging store will know about, like every other store does. But all of the logic around like sending that data back to the server to do analytics or whatever will be contained in that one store. So it's basically listening to the whole application. It's not going to ever emit change because nobody's listening to it, but it's going to receive all of the actions that happen in the application and be able to log them back to the server. So error handling. There's a couple of different ways to do this. This is for like optimistic updates and that sort of thing. One way to do it is with a client ID, or also called the dirty bit method. That's where, in the action, you would create a client ID, like using date now, like I just was showing, like some kind of hack to give it some unique value. And you would send that back to the server. So when the server comes back with an error or like an invalid message for whatever reason, it'll hand you back that client ID, and you can go back to the store and clean up after yourself. You might also have an error store that like knows to show a dialog and that kind of thing. But another way to do this is the way our upcoming framework called Relay does it, and that's with an actions queue. In Relay, we have a single store, which is based on a query language called GraphQL. So Relay is kind of like built on top of Flux, and it's an actual framework, and it's coming out later this year. But Relay requires that you use the GraphQL language on the server. So it's not for everybody, but it's a really great project. But the way they do error handling is very interesting. Inside of the GraphQL store, they have an actions queue where they just kind of collect all the actions in this like buffer, essentially. And then down in the getters, when they want to get data from the store, they pull from both the cached values that are in the store and from the actions queue, pull those together and then return them. So that's how Relay works, and that's another way of doing it, essentially. So another pattern is resolving your dependencies in the controller view. And this can be cool as long as it doesn't get out of control in terms of like putting a bunch of application logic in your view. But this is like essentially, like I was saying earlier, whenever you have a circular dependency between stores, you have store A needs to wait for store B, and store B needs to wait for store A in the same dispatch cycle, that can become a big problem. So one way to resolve that is having those stores not require each other and actually just resolve that down in the view. Another way is to do it in a third store. So like I said, it's usually the pattern there is whenever you find yourself in a circular dependency, you either are moving from 2 to 1 or from 2 to 3. And what the 3 is can be either an additional store or you can resolve it down in the controller view. So here's some anti-patterns for React and Flux. Putting getters in render. Getters really only belong in your controller views and only in getInitialState and in your onChange handler. It's really the only place you should be pulling data into the data flow. If you put getters in render, and I see interns make this exact mistake all the time, you're essentially just interrupting that data flow, and you're bringing in a new entry point into the data flow. And that's going to become very difficult to understand what's going on in your application when things grow. In addition, it's going to slow down your render method, because now you're like outside of React. You're calling out to like something else at some point. So another one is application state and logic and React components. When React components should have component state and component logic. But whenever things start to become shared across components, they really should be moving out to a store. Possibly a utils module, but usually it should go out to a store. And the last one is trying to define state from your props in getInitialState. And this has been documented on the React website. This is going to violate the kind of like the source of truth of data. If you take props and you try to like modify state and create some state values out of them directly, then suddenly it's like, where does this data really come from? State and props should be like very separate. And if you need to use props in the way that you're thinking you should use state, you should probably just like do some calculations in render very quickly, and then like the same things that you're trying to do in getInitialState. So so just at the end here, I want to talk about what Flux is related to. Flux is not really MVC. There is no controller. We have these controller views, but they aren't really controllers. They're just doing that movement of data from the model to the view. There is a split between the data layer and the view layer, similar to MVC, but that's true of many other application architectures. Flux is influenced by reactive and functional programming. It's influenced very strongly by data flow programming, where in data flow you have, not only are you highly cognizant of the data flow, but you also have in each component in the system, you have very distinct inputs and outputs. And that's very similar to the way the store has that one callback as the input, and the getters are the outputs. But more than anything, it's probably most closely, most similar to CQRS, which stands for Command Query Responsibility Segregation. In CQRS, you have a command that comes out and goes to the data layer where there are mutations that take place. And then there's a query that queries for those mutations and pulls it back to the view and re-renders. That's very similar to how the action gets distributed to the stores, and then we use the getters to query for that data and bring it back to the view. In CQRS, the command, however, is much more reified into a large object, as is the query. There's a query object that's being utilized. And so you could think of Flux as sort of like a very lightweight form of CQRS. But, you know, there's a lot of alphabet soup on the screen right now, but really this is the only 3 letters you really need to remember, and that is that Flux totally works. Thanks very much. And if